Yeah, so now let's plot the phenotypes for the first SIP and second SIP. Then we can do plot. Let's yeah, we probably you need to change from millions to 10,000. That I already have done that. Then we try again for the simulations. Okay, then now plotting the first SIPs and second SIPs. Then the plot looks like this, right? I wonder what is correlation between this y1 and y2. Ah, that is 0.15, right? So here, this is. So this plot is correlation of 0.15. That's not that much, right? So now also we can change probably heritability maybe higher from zero point 0.8. Then try again. Yeah, now its correlation can be increased, right? Then next we get back to heritability the same as before, and we change probably sample correlation as 1 like MZ twins, and try again. Yeah, then also compared to the first one, then it also correlation is increased like this, right? That is also shown in this value compared to 0.15 increased to 0.3, right? And yeah, then we also have whether that affect. So we get back to the full sieve again. Then now we change the number of record. Then try it. So now it's reduced. So it's flooded. Yeah, something like this. There is a number of record. But in this case, the phenotypic correlation compared to the first one, there is 0.15. So it's not much different. Actually this is high sampling error, large variance, right? Based on also this CI. So sometimes it gives 0, sometimes it gives 0.3. It's a lot fluctuating, but the mean should be similar to this. So what can you conclude from this exercise? So this correlation is increased when heritability increased or sample correlation is increased, right? But this is not the mean of the correlation is not affected by number of record. But this confidence interval is affected by number of record. However, this confidence interval uh, is not relevant to the heritability or sample correlation. Did that make sense? Also, probably we can check. Let's have a look. So we goes to get back to 10,000. Yeah, then whether using 0.3 or so let's say, so this is when we use 0.3, then now we increased heritability 0.8 and to see what happened. Can you see what is confidence interval? So this is around, we can do 0.3 minus 0.5. So this is the interval of the CI, right? Confidence interval, that's around 0.07. How about in this case? What is when heritability increased, then this interval is really changed or not? Actually, not much change, right? So it's quite similar. Also, maybe you may have give a very small value, 0.1, to see what happens. Then you get minus, yeah, that is 0.07. So these two values, a slight difference, but it's not much changed. So this standard error or confidence interval is robust against changing heritability. However, sample correlation, that probably I would guess robust as well. Probably you can check by yourself. Okay. Okay, then now in this code, siblings are, can you guess what is Sn? This value Sn, and what is if you change Sn equal 5? Then what does it mean? Can you estimate heritability with Sn equal 5? Can you estimate with this with different number? For example, you can change as 3. Then try. It doesn't work, right? It doesn't work. That is because, so this Sn is actually the number of members within each SIP. So I can draw in the whiteboard. I delete this. Yeah, so you have from the full SIP design or MZ design. So you have the SIP, the first SIP, and this is the second SIP, and this is family 1 to the family n, right? So you use the 10,000 in your simulation code 100 or millions before. So this is the number of record. So you have y1 to the yn. Actually, this should be first record for first SIP y11 and last record for first SIP yn1. You can call, and this should be 1, 2, first record, second SIP to the last record for the second SIP, right? So what you did, get the phenotypic correlation between this one and this one. So that is phenotypic correlation. We can call RP, then divided by the sample correlation between first SIP and second SIP. So in the case of full SIP, you can divide by 0.5. That's what you did to get heritability, right? But now the question is, what if there is more than 2 in one family? So in full SIP or half SIP, that's possible, right? Now this is y 1, 3. Sorry, this is y and 3. Then how you can get a phenotypic correlation using these 3 informations? Probably you can ignore this information, but then you lose some information that is available, right? That's not what you want. You should use all information available. Then what can you do? So that is the question from this slide, right? So in this case, Uh, yeah, in this case, that each family has different number of members, and also in each members that is possible uh, that some family has more number, like some family has like 4 or 5 members within family, but some family has only one record available, but this is not is always missing, something like this. So this is not balanced, right? From the different sieves, some are available, some are not, some are missing, but the other family, they are all available. So this is unbalanced design. So in this case, or number of members in one family is a lot more than 2, then what can you do? Also, in more complicated situation, probably there is complex pedigree. Then what can you do? That is question in the probably in general case. So in the case, so there is a linear mixed model, so that can be used uh, for this problem. Then when you use a linear mixed model, there is some key function, for example, probability density functions or likelihood. So that will covered in the next lecture or practical. Thank you very much.